Today I will show you how to undertake a thermal analysis on Excel. The problem we will solve is a 2D steady state conductivity problem with no added generation. Our block will have a thermal conductivity of 5 watts per meter Kelvin, an X length of 0.1 meter, a Y length of 0.1 meter, and we will discretize the block by 0.01 meters in the X and Y direction, which will give us 10 sections here and 10 sections here. So there will be 100 elements. 50 degrees will be applied on the top and bottom face, and then 0 on the left and right. So the cell you look at will have an I and J component. If you go up 1, the J is 1 less. If you go down 1, the J is 1 more. If you go to the left, the I component is 1 less, and if you go to the right, the I is 1 more. So for conduction, steady state, so the energy in equals the energy out. So the energy in minus the energy out equals 0. So for the energy in, for the X, it will be the negative thermal conductivity times by the temperature the cell you're looking at minus the temperature of the cell to the left over the discretized X. And then for the Y, it will be the cell you're looking at minus the cell above over Y. And then for the energy out, it's the same, but this time the temperature will be the temperature to the cell on the right minus the left, and then the cell below minus the cell you're looking at. And then this is just simplified down into this equation. So this is for this cell, and then you can do this for all the cells. And on Excel, you plug these equations in here. So it will contain, so this is the cell you're looking at, and then it uses equations for the one to the left, the one above, the one to the right, and the one below. And then these equations all equal 0. So then on Excel, you go into a solver, and then you make all these equations equal to 0 on this duplicated version of this. And then it will just show you the temperature. It will run an iterative solver and then show you the temperature, which makes these equations equal to 0. So as you can see, there's 50 degrees applied to this edge, 0 here, 0 here, exactly the same as our problem, 50 here, with the same constant. And then you get this temperature distribution, which makes sense as the hottest temperatures are found in the middle of the hot edges, and the coldest temperatures are shown here at the sides next to 0 degrees. I will now show you this in Excel. So it's another 2D analysis. And then we just sketch 100 millimeters up and down, create a surface, and that's our body done. Then in mechanical, it's 2D plane stress behavior. Then we apply the mesh, and this will be identical to the mesh that we create in Excel. So we just apply face sizing, and then edge sizing with hard behavior of 10 millimeters. So there'll be 10 elements down, 10 elements along, so 100. So the same as the Excel. And this is an FEA analysis, so it's finite element analysis, and it's called finite because you can't do an infinite number of elements, so you have to mesh and get a certain number of elements. And this is discretizing, so we're discretizing this block surface to 100, and then it interpolates the values between here. It calculates them where they cross and then interpolates them so you can cover the whole thing, even though you're only calculating 100 different points. So then we simply apply the 50 degrees here at the top, 50 degrees at the bottom, and then 0 degrees at the side, with initial temperature of 0. And then you simply apply a temperature solution, Then as you can see here, it gives the same value as Excel with the hot temperatures here, the cool temperatures here, hot here, cool here. Now if we compare, we are getting around 42 in the middle of the hot surface, 42 here, and then 25 in the center, and around about 7 to 8 at the left and right hand sides. And look with a probe. So as you can see, instead of 42, we're getting about 43. And this one's closer to 42, so it's very close to what Excel's giving. These are giving around just over 8, while Excel was giving just under 8. And then right in the middle, we're getting the same 25 degrees. So you can see Excel and Ansys are giving a very similar result, which shows that for these simple problems, you can actually use Excel instead of Ansys to give you a temperature distribution. Thank you for watching.